Hello and welcome to today's mathematics class. For this class, we'll look at the concept of trigonometry. So, an aspect called double angle. Let's look at the concept that governs double angles, half range angle, um, half angle, and triple angles, right? So look at double angle formula, the half angle formula, and the triple angle formula. For this class, we'll focus more on the concept of double angle formula and how to prove them, right? And then we'll look at what we refer to as half range angle formula. So mind you, half range angle formula is different from half angle formula. So look at a very two concepts starting from double angle formula and half range angle formula. Next class, we'll look at what we refer to as half angle formula. Then we'll look at triple angle formula. Let's start with this concept of double angle formula. When it comes to double angle formula, we are considering just three identity. That's sine, cos, and tan, right? So I'll give you I'll give you the several double angle formula on the board here, and we'll try to prove them one after the other, right? Because in exam, it comes in exam that you'll be told to prove them in some cases. So I can't just give you know how to prove them because it comes in exam, so that they'll ask you to prove them in exam. So when it comes to an exam, how do you prove them? That's the concept now. So you need to learn how to prove, because trigonometry is all about proving, right? So let's start with this, please. When it comes to double angle, we said we are considering for sine, cos, and tan. So let's start with sine, please. So if I'm given sine 2a, because it says it's double angle, so my angle there becomes to double. That's sine 2a. So for sine 2a, what's your expression? That becomes 2 sine a cos a. So when I'm given for sine, if I have sine 2a, the expression becomes 2 sine a cos a. That's for sine. For cos 2a, that becomes for cos 2a, there are three expressions for cos 2a. For sine 2a, just one expression. What's the expression? That's 2 sine a cos a. But for cos 2a, I have three distinct expressions for cos 2a. The first one is that if I have cos 2a, it can be expressed as cos squared a minus sine squared a. This is your first expression for cos 2a. The other expression for cos 2a is given as 1 minus 2 sine squared a. This becomes another expression for cos 2a. Or the last expression is given as 2 cos squared a minus 1. These are like the three expressions for only cos 2a, please. So know this man, please. So we have done sine, cos. Let's do tan. For tan, look up, please. For tan 2a, this equal to 2 tan a all over 1 minus tan squared a. So this becomes your mathematical expression for sine 2a, cos 2a, and tan 2a. Let's now look at sine and cos in terms of tan. So let's look at still on double angle, but this is for sine and cos alone, Abi. Let's now see how we express sine and cos in terms of tan. What do I mean? Another one is that if I have sine 2a, this equal to 2 tan a all over 1 plus tan squared a. This is sine in terms of tan, please. So note this expression. So this is sine 2a in terms of tan, please. So note that for sine 2a, there are two formulas there, in terms of sine and cos, and in terms of what? Tan. So I have this. Also note that for cos 2a, for cos 2a in terms of tan becomes 1 minus tan squared a all over 1 plus tan squared a. So this becomes your mathematical expression for cos 2a. So when it comes to cos 2a, I can express cos 2a in 1, 2, 3, 4, in 1, 2, 3, and still be correct. And also, I can express cos 2a in terms of tan. How? This becomes the expression. Please, just the task now is that just master this concept. That's all. So master this concept and you're off, please. All right, let's look at how to prove this one after the other. I should have go ahead to give you questions on this and look at how to solve past questions on this. But by the way, you should know how to prove it, because in exams it comes in a way that they'll give you that given sine 2a, or perhaps they can tell you that prove that sine 2a is equal to 2 sine a cos a. How do you do that? They can ask you that prove that cos 2a is equal to cos squared a minus sine squared a. How do you do that? Please. They can still ask you that tan 2a is equals to 2 tan a over 1 minus tan squared a. Prove it. How do you do proving, please? Let's look at the proving concept now. Let's look at proving, please. Let's look at how to prove this concept, please. So let's start with the first one called the sine 2a. For sine 2a, sine 2a. This is the expression here. Let's now prove why sine 2a is this. Now listen up, please. For sine 2a, I can express sine 2a in this manner. Look up. This becomes sine into a plus a. Look up. We know that a plus a will give 2a, right? So a plus a will give 2a. That's so sine, this becomes sine 2a in another expression. So I'm saying sine 2a can be expressed as sine a plus a. We see the same thing, right? Now, looking at this will take me back to what we refer to as the concept of compound angle. I've done a video on compound angle, right? I'll drop the link to compound angle in the description of this video. So if you're familiar with compound angle, this should not be a problem, right? So for this one here, go back to your compound angle concept. We said if I have sine a plus b, this equal to sine a cos b plus sine b cos a. This was from idea of compound angle, right? This man here was derived from the concept of compound angle, right? So I apply this technique to solve this one here. But mind you, I'm having AA here, not AB. So I'll still express in the same way. So if I express sine A plus A, that becomes sine A cos B. So that becomes sine A cos A in this case. Here was AA, here was AB. So I'll just express in the same way. So I'll have here becomes sine A, then cos A, then sine A cos A in this place here. That becomes plus sine A cos A. So I have this. So I have this expression here. All right. At this point now, what do you get? Look up, please. At this point, observe that there's some terms that are common. Sine A is common. Also, sine A is common. Similarly, cos A is common. Also, cos A too is common. I can choose to pick out one of the two, right? So let's say I pick out sine. You can pick out cos or sine, any of the two. Let's say I want to pick out what's it called? Cos, for instance. So cos is common. That becomes cos A into what? Sine A plus sine A. Observe. Cos A, sine A times cos A. That's sine A cos A. Similarly, sine A times cos A. I still have the same thing here. So it becomes your idea of factorizing. So cos A is common. I bring it out. Similarly, you can choose to bring out sine A and sine A if you want to. But see, it's the same thing, please. From here, what I get from here, this can be written as this cos A into Observe that sine A plus sine A, we give 2 sine A. That becomes a 2 sine A. Multiply the two of them, so that becomes 2 sine A. Next up, cos A. This becomes how we got sine 2A as being equal to 2 sine A cos A. So this becomes your first proof to that man here. So we have proved this one as being correct, as you can see in front of you. Let's look at cos 2A, right? And let's see what we get. All right, for cos 2A there, let's prove for cos 2A. We said if I have cos 2A, this can be broken down as what? Cos into A plus A. So I have this. So cos 2A can be expressed as cos A plus A. All right, if this man is true, yeah, go back to your compound angle concept again, right? That if I have cos A plus B, this will give what there? Cos A cos B minus sine A sine B. This was an idea of compound angle for this one here, compound angle concept. So apply the same thing here. If this was A and A, so everything will be what? In terms of A. So this is now equal to, I will have cos A cos B. So in this case it becomes cos A cos A, right, minus, right, sine A, next up sine B. So I have this. So note that when it comes to, what's it called? When it comes to cos A plus B, I have that expression. But in this case, it is in terms of what? A and A. In terms of A and A. So everything becomes A, all true. Sorry, this becomes A, all true. So I have A here. So I have this. All right, at this point now, what's the next task? Observe that cos A is multiplying cos A. Similarly, sine A is still multiplying sine A. What's the concept? This becomes, if cos A multiply cos A, I'll have cos squared A minus, if sine A multiplies sine A, I'll have sine squared A. These are first proving for cos 2A as being equal to cos squared A minus sine squared A. I have proved this one, right? Let's see how we arrive to this other expression for cos 2A. Similarly, listen up. We said cos 2A can be expressed as what? Cos squared A minus sine squared A. So I have this, right? So I have this here. At this point now, listen up. We just said that cos 2A is equal to cos squared A minus sine squared A. That's true. And I showed you that this is it here. Let's say we get to this and this value. Let's say we get to it there. Now from here now, go back to your normal trigonometric functions, identities, right? Let's start with cos. Not that, but at this point now, but we said cos squared A is equal to what? 1 minus sine squared A. At this point, you should know your trig function identity, right? It becomes identity that says that if I have cos squared A plus sine squared A equal to 1, right? This is your what's it called? Fundamental trigonometry function, the identity, right? So if I make cos A subject, this one will move here, becomes a minus sine A, right? So anywhere I see cos squared A here, I'll put what? Minus sine squared A. So I'll have that. I can express cos 2A as being equal to, say, cos squared A should be what? This one here. That becomes 1 minus sine squared A, right? Minus, this one becomes sine squared A, right? So I have this. What do we get from here? So cos 2A can be expressed as, listen up, minus, if I have minus 2 minus 2, that's what? Minus 4, right? Similarly, if I have minus A, that's minus 2A. So this becomes 1 minus sine A gives minus sine, that minus what? Minus 2 sine A sine squared A, right? So 2 of it becomes minus 2 sine squared A. This is how I got to this expression for cos 2A as being equal to 1 minus 2 sine squared A. Let's see how we got to 2 cos squared A minus 1, right? Similarly, I'll still put out this expression that we said cos 2A is still equal to what? Cos squared A minus sine squared A. In this first case here, we said we pick out cos. Let's not pick out sine, but sine squared A should be equal to, from here becomes 1 minus cos squared A, right? Just take cos squared A to the other side here, becomes a minus, right? So what I get from here, anyway, I see sine squared A, I will replace this as being equal to this. This becomes, I can express cos 2A as being equal to, we said I'll have cos squared A minus this sine squared A as this value, that becomes into 1 minus cos squared A. So I have this. All right, I'll use this negative sign to expand this bracket. So what do I get in essence? From here now, I'll have cos 2A as being equal to, listen up please, I'll have cos squared A minus times 1 is what? Minus 1. Next up, minus is what? Plus. Then I have a cos squared A. Mind you, cos squared A plus cos squared A, that will give us 2 cos squared A. So that this becomes so from here now, all right, from here now I'll have that cos 2A can be expressed as cos squared A plus cos squared A. That becomes a 2 cos squared A minus this one here, minus 1. So this becomes the third proof that cos squared A is equal to 2 cos squared A minus 1, as you have seen in front of you there. All right, let's look at how we got tan 2A as being equal to 2 tan A all over 1 minus tan squared A. Let's see how that works. We said from there, if I have next up, if I have tan 2A, this becomes tan into A plus A. Similarly, go back to your idea of compound angle, as we said earlier. For the compound angle concept, the idea is that if I'm having tan A plus A, for A plus A is still the same thing as 2A, right? As we said earlier here, from here. So go back to your compound angle concept. For compound angle, if I have if I have a tan A plus B, right? This becomes what there? Tan A plus tan B all over 1 minus tan A tan B. This one here is your idea of compound angle. So if I've got an idea of compound angle, what next? That's nice that I'll express this one in terms of AA. This is AA, right? So everything here should be in terms of A. So this becomes, if I have tan 2A, it can be expressed as what? Tan A, observe, tan A plus, here was B, but here it was A, yeah? It was A, B, A. So anywhere I see B, it should be A. So that becomes tan A, similarly, all over, this is 1 here, minus tan A, I have a tan A, next up tan B, but in this case we was under tan A because I'm having AA here, not tan A, not A and B, it was AA. Everything should be in terms of A. That's the logic there. At this point now, this is now equal to tan A plus tan A is 2 tan A. That becomes what there? A 2 tan A all over this 1 minus tan A times tan A. That becomes tan squared A. This becomes the proving on how I got tan 2A as being equal to 2 tan A all over 1 minus tan squared A. That becomes the proving to this particular task here. So I have this as being the proving to this place. All right, let's look at how we can express sine in terms of tan this way, right? Let's look at this proving and we're off for double angle. We'll now look at the concept of half range angle formula, right? You know, we said we have half angle formula is different from half range angle formula. So look at the concept of half range, right? So look at half range formula. So from here, this for okay. We said we'll clean this part. All right, at this point now, let's do how we can express sine 2A in terms of tan, right? And let's see what we get. Welcome back. Let's look at yet how to prove sine 2A in terms of 2 tan A all over 1 plus tan squared A. Right, so we look at how to prove that sine 2A has been equal to this. We did this earlier. So without stressing myself, I'll work on this answer straightforward. So we said this becomes we said sine 2A, that sine 2A can be expressed as what? 2 sine A, next up, cos A, as proved in this case, right? Now at this point, I'll divide this one here all over 1 this way. That's the tax. Divide the answer here over 1. Now, but I can say sine and cos here. But we know that cos squared A plus sine squared A is being equal to 1. So anywhere I see 1, I'll put cos squared A plus sine squared A. That's the tax. So I'll be having that sine 2A can be expressed as everything here, numerator, 2 sine A cos A all over, listen up please, I'll have what there? A what? A cos squared A plus sine squared A. Anywhere you see 1, put what? All the value here. So I have this here. Now at this point here, after dividing the denominator by cos squared A plus sine squared A, the task now is that I will divide each of them by what? Cos squared A. So at this point, just master it please. Divide by cos squared A. If I divide by cos squared A, what do I get? I'll start with my numerator. Sine 2A can be expressed as 2 sine A cos A all over, we said divide by what? Cos squared A. I'm done with numerator. All over, this is for numerator alone. Now, the denominator is still there. So I have cos squared A all over that same cos squared A plus, we said divide each of them, sine squared A all over by what there? By cos squared A. So I have this one here. So from here now, we know that cos squared A will cancel out one of these. So we have just a cos squared A down here, right? So the task now is that if I have sine A over cos A, that's what it expressed now. Last slide, we said tan A equal to what? Sine A over cos A. So whenever I see sine A over cos A, I'll put tan A. So observe that at this point now, sine 2A can be expressed as, this is 2. Next up, sine A over cos A. That's what there, a tan A all over. If cos squared A cancel out cos squared A, that's just 1. That becomes 1. Next up, plus, this is sine A over cos A. Similarly, sine squared A over cos squared is what? A tan squared A. This becomes the proving on how sine 2A can be expressed in terms of tan. So I have this expression here. Let's look at how you can express cos 2A in terms of tan 2, right? And we're off. So we said, check your note. When we proved for tan 2A, our very first expression was just cos 2A minus sine 2A. Now, I'll just recall this man back. So we said earlier that cos, what's there? Cos 2A, right, is equal to, that becomes a cos squared A minus sine squared A. So I have a cos squared A minus sine squared A. Now at this point here, similar procedure, divide this by what? By 1, right? Similar procedure, divide that answer by 1, which I have here. You now say but, similarly, I'll have but, we said that cos squared A plus sine squared A is equal to 1. So whenever I see 1, I'll replace that 1 as being equal to cos squared A plus sine squared A. That's that. So I'll have that cos 2A is equal to, numerator, I have cos squared A minus sine squared A, right? So all over, we said 1. Anywhere you see 1, put what? Cos squared A plus sine squared A. So I have cos squared A plus sine squared A. I have this here. We said at this point, divide by what? Cos squared A. Similarly, I what? Divide by what there? Cos squared A, right? So what do I get from here? I said divide each of them, each term, by that what? Cos squared A. So I'll divide each term by that cos squared A. So I have this. So let's see. So cos 2A now can be expressed as, pick out numerator, cos squared A over, divide by cos squared A. Cos squared A minus, this is sine squared A, divide by that same word, cos squared A. I have this, right? I have this. So all over, that's for numerator alone. Next up, denominator becomes cos squared A over, we said divide by what? Cos squared A, right? This is plus, this is what? Sine squared A over, we said divide by what? Cos squared A. Cos squared A. So I have this. At this point now, you can see that this one will cancel out this, right? So this one again, this one cancel out this. So I have a 1 1, which is same thing as this 1 1 here, right? So what do I get from here? Cos 2A now, cos 2A can be expressed as, said, divide this by this. I'll have just 1 minus, we said sine squared A over cos squared A represent tan squared A. So I'll have what? A tan squared A here, all over, listen up, cos squared A divided by cos squared A is still 1. Is still 1. This is a plus. This becomes what? A tan squared A. This becomes your answer on how to prove this concept, as you can see in front of you. All right, this becomes your idea behind this concept. So next class, we'll look at how to prove the concept of half angle formula, right? So that's next class, please. Start look at that, please. If you found this class helpful, do it to like, hit the bell icon, subscribe to my channel, share to your friends and classmates so they can learn too. All right, see you in our next class.